now. And Roy, great to see you. It's
always good to
see you. You feeling ready?
Yes, definitely.
Very good. Roy is no stranger to the Apidays track. He is no stranger to GraphQL tracks by any means. And based on his chat there, which you can message him as well, no stranger to government data. But this talk is not about government data. It's about microservices. So I'm going to give you the stage that you have your full say here. And yeah, show us what you got.
Yeah, thanks, Jesse. I believe it was last year or the year before I spoke at Apidays about government data. So if you want to look back about how the Netherlands is doing this, or at least City of Amsterdam, then go back and find that recording. But today is about GraphQL and GraphQL for microservices. And every time I talk about microservices or talk about GraphQL or work with distributed teams, not everyone is a fan of microservices. At least it's something I came to know. And this is a meme I found somewhere. It's whenever your boss is telling you we're going to microservices, or maybe it's not your boss, maybe it's your architect or somewhere else. I believe microservices are really nice, but they aren't for everyone. So if you are coming to this talk to see if you need to convert to microservices, then you should probably watch a different talk, because this talks about if you already have the microservices and you want to bring them closer together by using GraphQL. If you're thinking about start using microservices, then well, it's probably a whole different discussion. Me personally, I'm a big fan of microservices, but it's a means to an end. So if you have a pretty working monolith and you don't have millions of users using your APIs every day, maybe you shouldn't be using microservices unless you want to build shiny tools. But it's a different discussion. So today is about GraphQL and microservices, and more specifically, how the two can work very well together. So I'll be showing the advantages later on. But you can imagine that if you have distributed services, every distributed service will have their own microservice, and that is sort of the start point for this talk. A little bit about myself. I believe you already got a brief introduction. So my name is Roy. You can find me on Twitter with the handle @hackteam. I'm doing tons of stuff in the GraphQL, TypeScript, React kind of space. Entrepreneur, started multiple companies, software engineer, author, and also a speaker from Amsterdam in the Netherlands. Currently, I work with a company called Stepzen, and they build a tool to build GraphQL APIs out of a existing data source, which is pretty cool. You might also know me from my books. About a year ago, I released Full Stack GraphQL. So if you're into building service yourself and you want to learn everything from the trenches and really build that server from the ground up, have a look at that book. If you want to know more about me, also, well, feel free to ping me on Twitter. As we're in the GraphQL track, you probably already know a bit about GraphQL. I believe at the beginning of this day, there was also a short introduction slide to GraphQL. So the thing GraphQL is really good at is helping frontends, especially frontends, with getting data and getting data in a format they really want. And also it all starts with the schema, right? So this is actually perfect for microservices, because if you have a microservice, it's typically isolated from other services. It needs to export some sort of schema. It can be types. So I see microservices built with TypeScript or Scala or any other language that's based on the type system. They export types. So a type system can be sort of the schema for your microservice. It can also be a REST API with some Swagger specification. It can also be a GraphQL API that is, well, releasing a GraphQL API, GraphQL schema that can be used by other APIs. So GraphQL typically is perfect for microservices because a service is isolated. A service has some sort of schema, which can be in different formats. And GraphQL is also working with schemas because GraphQL is all about graphs. And this is really a nice thing about GraphQL, because if you have the graph, if you have the schema, it's a starting point for every service or API that you're running. So whenever you try to explore new services or new GraphQL APIs, have a look at their schema, have a look at their graph. And then you get to know a lot about this service, because the schema is really tied to the thing the GraphQL server is doing for you. And the same is for the microservices, right? Because they are domain-based. So typically, if you start a microservice architecture, you're trying to split things up. So you have maybe authorization microservice. You have one to get information from a specific database or from a specific part of your business. Then you have another microservice that gets data from maybe an external partner, and you're normalizing some data in there. And these are things you typically see in every microservice architecture, because they should be domain based. If you have microservices that are doing multiple things, getting data from multiple services, then it's probably not the best microservice. And maybe you're in a phase that you're splitting up your monolith, and you have these strange kind of services hanging around that someone tried to decouple. That's maybe not the best example for microservice, because a real microservice is domain based and is doing just one domain. And then there's different flavors within microservices, of course. There are people saying that maybe one microservices that are getting payment information should be split in 6 different microservices to get the payment information from all different sources and these kind of things. But typically, I would say domain or business based. So if you look at this example, you maybe have a client that is consuming multiple microservices, and this is an example without any data layer or API gateway in there in between, because there's also different flavors in there. You can call your microservices directly from your client, or maybe you have a gateway or a data layer or something else in between. But a good thing to know, every service has its own domain. So if this is your client and it's talking with these services, then all these microservices will have their own domain, and they will do their own thing. And you could think on later on, if you work with GraphQL, then maybe every service will have their own schema because it has their own domain. So if we look at a more detailed example here, so this is the same client, and now the services have got a name. So you've got your authorization service or your authentication service. Typically, your client would request a token, either with OAuth or maybe with client credentials. Then the service would bring back the token. Then your client can send a request to any of the other services with that token to get information. And if you have microservices, then typically these services don't talk with each other. So your microservices have no interaction with each other. They only know how to respond to certain input and then give you certain output. So that's what I really like about microservices. They should be decoupled. They shouldn't be interacting with each other. So your user servers shouldn't know there is an authentication service. The only thing it should know is that if it has a token, it can validate the token, then it should return data. So this is a really nice, powerful way to decouple your microservices and really make sure that they aren't connected with each other. And if you would have a monolith architecture, then probably all these things will be connected. Controllers are calling each other from within the monolith, which is perfectly fine for most services, because if we'll be honest with each other, what will be the point that you readily have hundreds of thousands of millions of users using your service? For most companies, that's just something they want, but something that might not be within their reach. So microservices are isolated; they're domain-based, and therefore they can also have its own graph. So all the services we saw, we had an authentication service, we had a user service, we had a post service. They can have their own graph, because typically they will already have their own specification. So your out service, if it's built on REST, it should have an API or Swagger specification. If it's built with GraphQL, it probably has its own schema already. If it's built with a language that has a type system, let's say TypeScript, Scala, maybe something else, maybe some language with a type system built next to it, it will release those type system specifications to other services. So your out service should have some sort of declaration of what it will take as input and what it will give as output. And it's the same will go for every other service. So the user service will also know if you request a user with a token and an ID, it should output the user in a certain format. So these are things you already have in your microservice. And the same goes for post. But if you have them with GraphQL, you can actually determine what kind of data will be returned. So if you have a sort of static type system or static input-output definitions, then probably every time you request a token for your out service, it will return all the information that the out service have. But if you put GraphQL on top of this, the microservice can actually determine based on your request what data should be returned. And if you already have a type definition for your service, if you have a Swagger or an API definition, it can be pretty easy to put GraphQL on top of this. And there are multiple ways to do this. I'll be showing you an example later on. But it's a nice thing of GraphQL. It's just specification. You can put it basically on top of a lot of different things, on top of existing specifications, but also on top of existing architectures that are using these specifications. Because all the domains, all your microservices can have their own graph. And by having a graph, it can have their own schema. And you can actually bring these schemas together. So in GraphQL, you can determine to bring certain schemas together. There are multiple patterns for this, which I'll also will bring up in a bit. But the nice thing about GraphQL is if you have all these different services that have their own schema, there is a way to bring them all together. And to bring them together, you would create like a data layer or an API gateway or an API mesh or data mesh. There's tons of ways out there to do it and tons of namings. And usually they don't, they are not that different from each other. Usually it's just a potato. It's the same name for the different, it's the same different name for the same implementation. But I typically call it a data layer because an API gateway also exists for APIs that are not for GraphQL. A data layer is somehow neutral word because you bring it together data and a layer, and it can be GraphQL, it can be anything else. And as you see, we also have a client. So we have a client that wants to interact with something, and therefore for me it makes sense to have to call it a data layer. And as you can see here, we've wrapped all the different services. So you would have a out service, a user service, and a pod service, and they interact with each other through the data layer. So from your client, you have just one point of entry, which will be your data layer or API gateway or whatever you like to call it. And that data layer will get the data for you from all these different microservices. So whenever you request a token from your out service, the data layer will receive the token, will probably store it, and then return it back to the user service. And whenever you request a user, probably there will also be some sort of interaction between the out service and the user service, but this will be all done through the data layer. So still your microservices have no connection with each other. And typically I would say a microservice shouldn't even know that a different microservice exists. So the data layer knows all these different services are out there, but your microservices, they have no idea if the other services somewhere in your architecture. Which is really the power of this, because if your out service doesn't know whatever it's providing tokens for, it's way easier to reuse that out service for anything else. So maybe you have some scopes defined in your out service. You can also define them in your data layer and then pass the scopes to your out service to handle it whatever you like. But by having this data layer, you can combine the schemas up there. And as I said, there are multiple patterns for this. So merging GraphQL schemas can be done in multiple ways. And merging is one word for it, because basically what you're doing, you have schemas. Schemas have type definitions in there, and by bringing schemas together, you can reuse type definitions from underlying schemas and maybe like a master schema. As I said, there are multiple ways for it. So some like to call it a master schema, some like to call it like your preference schema or your top schema. There are multiple ways to do so, which is also a bit showing the age of GraphQL, because GraphQL isn't that old yet. We have a specification. There is a new specification out there since maybe 1 or 2 months. And it doesn't really talk about merging GraphQL schemas together because, well, that's something the industry is doing for you and not really the specification just yet. Maybe that will change in some way. But there are multiple ways to bring these schemas together. So one way to do so is schema stitching. And this is a really nice way if you build your own GraphQL server. So if you're working with Apollo server, you're working with Express GraphQL, you're working with any of the other GraphQL server libraries out there, you can do schema stitching in there. The Guild has a lot of tools in their GraphQL tools. So there are some tools there to bring schemas together, to merge types. And schema stitching is a really nice way. But typically it defines you to write a lot of code. So to do schema stitching, you need to create a server. You need to define your schema. You need to tell the schema where certain data comes from. And then sometimes, depending on where you should get your data from, you also need to write resolver code. And by writing resolver code, it might already get a bit too complicated. And one of the downsides I see for schema stitching is also that if you want to write a server that brings together all these underlying GraphQL servers, it's pretty easy to duplicate business logic or bring domain logic into a separate layer that you really need to configure and write code for, which can be perfectly fine, but it's also something that brings a lot of overhead because you need to define all the code there, you need to bring together these different things. But like I said, if you have a small implementation or if you like to write a lot of code, then schema stitching is a really nice way to bring together different schemas. And then a different flavor is federation. So federation is an approach where you bring together schemas based on the schema only and not so much the resolver. So there are some federation libraries out there that ask for you to bring together microservices by changing resolver code. And typically it is something I dislike, because if you need to write resolver code in order to support federation, then you're also bringing extra dependencies into your GraphQL servers and your GraphQL microservices. But still, it's a pretty nice way. And federation is, I will show you an example later on. It can be done with multiple libraries. It can be done with multiple services. And to me, federation really is a way to bring together GraphQL services through their schema in some sort of ground schema in which you bring all the things together. And then ground schema might sound like a Ponzi schema, but it really isn't. So maybe top schema is indeed a better way to name this. And then you also have something like remote schemas, which will say you put schemas in a schema registry, which will mean basically that every service has their own schema, and they somehow publish them through like a schema registry, or well, they will just publish them on their own endpoint and you bring them all together. So this is a really nice way to bring together remote schemas or services that you maybe don't maintain yourself, or schemas that you want to be available multiple ways. So maybe you have one service that you want to make public. So you want to have just a GraphQL schema of that certain service available, maybe in the cloud, maybe behind some sort of proxy. And then you also want to bring them together in a different schema. So remote schemas are a nice way to do this. And there's a lot of overlap between federation and remote schemas. And the example I'll be showing you, it's I would say it's a combination of remote schemas and federation, depending on how you use it. So as soon as if you federate your services, it's a really nice way to do it on top of what you already have. If you have remote schemas, it's sort of like a step in between to have federation. So you can federate remote schemas. You can also just have remote schemas that you bring together using maybe schema stitching or something else. So it's a bit of an overarching term. So I think it's best to have a look at an example. And for this example, we'll be using a service called Stepzen. And with Stepzen, you can create a GraphQL API out of existing data sources. So it looks a bit like this if you want to put it in a schema. So you can connect almost any backend or data source. So that can be a SQL database. And then in SQL, we have multiple flavors, of course. You have MySQL, you have MSS SQL, you have Postgres, which is also using well, some sort of SQL. And you can all just do through directives. So what Stepzen does is truly bringing schemas together on a directive basis. So instead of writing resolvers, you write directives that will be handled in the cloud. And based on your directives, the data will be pulled from any data source. And you can also do it from REST APIs or NoSQL APIs that expose a REST API, and even from other GraphQL APIs. So with a tool like Stepzen, you can federate based on microservices that have either GraphQL or REST implementation. I would say you can also bring together microservices that have a database, but then it's well, it's not really microservices anymore. But you could, in theory, put Stepzen on top of your microservice and then expose a schema for that microservice that is just a SQL database or any other database, and then bring them together in a different Stepzen instance to really connect them together. But it's not what we'll be doing today. So today we'll be looking at bringing together REST APIs or GraphQL APIs. And the nice thing of this is that it will already get you a performance serverless GraphQL API. So you don't have to worry about deployment. And I'll show you once we look at some code examples. So the thing you'll do, you create your GraphQL schema. You basically connect the information you want to connect, and then it will create a serverless GraphQL API for you. So if we want to try this out, then we'll be switching my screen to this code example. Also, let me zoom in for you a bit. So what I'm doing here, it's basically just I've created 3 microservices. So I have a microservice called auth, and this actually translates to the thing we already saw in the presentation. So I have an authorization service. It's not that much code. It's just like a simple JSON server. So it's nothing too fancy. It's just for well, demo principles. I am a dev role and actually implemented authentication, so maybe nice to cheer for me a bit in there too. So I have an out service, I have a post service, I have a user service, and these are just basically bringing me mock data. And I can show you one of these services. So these are REST APIs. And these REST APIs will give me an endpoint, something like this. /posts. It's the local tunnel. It's actually unauthorized because, of course, I have authorization implemented. So let me get to this example. So what it will do, it actually returns just this JSON blob. So whenever I pass a token to it, it will return this JSON blob. And passing a token to it, it actually takes me a lot of time right now, of course, because I haven't implemented anything else, and I would need a client in order to get the token, or I need to send a request to my out service to get this token before I can pass it to the REST API. So what I've done in this example actually is I've added Stepzen to it, and for any of my services, instead of having just a REST API endpoint, I created a GraphQL schema for it. So my authorization service, it does multiple things, but most of all, it returns the authorization type. And this authorization type has maybe multiple fields, but the only thing I care about is the ID, which is probably my user ID, and then my access token, which will be a string, and this will be a typical bearer token. And what it does, it has one query, and the query is called token. It returns the type auth, and I also have this endpoint. And then all I can do is just bring these things together and then run it like this. And then it will return this. So where is my? Oh, here it is. It will return this GraphQL server in which I can do some things to get the token. We get the token, what is called access token here. And then I have some other things implemented here to bring together these services within the data layer. And within all these different GraphQL files, I'm also bringing together data like this, which is quite cool. And I'll be sharing you the example later on because we don't have all day to do this thing. But the example you would have with Stepzen is you create your microservices as graphs. And then you create a schema for each microservice, unless they already support GraphQL. This looks a bit like this. So as I showed you in the code example, you have a GraphQL schema for every service. And every service will have their own schema, and then you bring them together with just GraphQL schema design language. And GraphQL SDL is basically the language in GraphQL in which you create GraphQL schemas. And this will be done from a data layer. So in my code example, I have one file called datalayer.graphql. And this is where I bring together all the different GraphQL schemas I have for every service. So every service will be connected through one data layer, which is quite nice because if you don't use the data layer, all the services itself, they can already be accessed and are able to get this data for you. So merging them together will be done from this data layer, which is giving you great examples because all the services already have their schema, so you can access them individually. And then through the data layer, you can create a code. You can write a configuration actually because you don't need to write any code, but you will use this configuration to bring them together. So you'll be able to get data from multiple graphs at the same time. And then using this example, you can deploy them serverless without having to write any pipelines, which is a nice addition of this. And by being able to deploy them serverless, the cool thing there is that if you build your own service, you don't have to write anything to make sure that those underlying services are also there, because your underlying services can still be deployed through your own CI/CD, and then only this data layer will be deployed without a pipeline using Stepzen. So it gives you the example that you don't need to maintain different infrastructures. You only need to maintain your existing infrastructure and then have this data layer on top of it. So all the people that are already using your code, they can still keep using your APIs. And then the clients that you want to use this data layer, they can use this data layer in order to get the data through GraphQL. And then this is an example for microservices, but the same paradigm are still there for monoliths. So in your monolith, you maybe have different API endpoints. If you would see them as different microservices or as different specification, then every endpoint can have their own schema. And then those schemas can be merged together in one schema altogether.
I'm gonna have to step in here, Roy. We're just coming up onto the time here. Fantastic talk. And you need to follow Roy because he is always posting content like this. There was one comment I want to give you 1 minute to respond to, a question about somebody concerned that a data layer acts as a single surface or a single point of failure in a stack. If you have like a 30-second response to that concern, because it's one we hear a lot in this architecture paradigm.
Yeah. So if you go to the code example, you can find it on this repository. You can find that we do it there. So basically the thing is you have something called a Sequence Directive, and in there you can define steps. So if any of those steps fails, you can have like an escape hatch. And it's the same with anything. If you have multiple endpoints that you're calling from your client, then still if any of those endpoints fails, you need to handle it somehow. So I would say handle it in a data layer and return maybe part of response. And this is where GraphQL comes good in. So you can send back part of the response, and then if your client handle the data that you didn't get there. So it's, you still need to implement that somehow, but then it would be nice to have it in a data layer so you don't break your client.
And you can standardize your error handling across your services too, which is a nice thing too. Roy, thank you so much for the chat. Sorry, I had to cut you off.
Okay.
Always great content, really fantastic stuff. This is a huge, complex topic, and definitely follow Roy at GetHackTeam because he's always got stuff like this out there. So thanks again, Roy. Really appreciate it, and we'll see you around.
Thanks, everyone, and enjoy the rest of the day.